Welcome to my little dungeon on flat earth science. I've replaced the lights, but that didn't help, they actually got worse. I put these extra lights here to try and light the place up. It's still nowhere as good as anywhere else in the house, but this is where I operate. Today, this is going to be a world first. I don't think you've ever come across a flat earther who's trying to explain how Venus works on the flat earth, because no one knows the proper flat earth model. I've got the only flat earth model, so everything works with it. They can't debunk it. They can argue, spinning ballers can argue about it because they have their BS and they made everything suit the ball, but really, no, they can't, because it all adds up to reality. If you haven't seen my previous videos, go check them out. But what I have to do is make this adjustment to my theory or naming positions of our seasons. Now, all along I've been using these terms here, aphelion and perihelion. I know scientists have taken some original words and used them on their spinning ball over the years, so I thought that must be the terms I should be using to represent the southern summer when the sun's down facing out that way, and I'll put aphelion up here for the northern summer. I knew all along they were the wrong terms compared to science. I thought they would have to do with my flat earth analogy, but really I've come across, I understood these with the moon, so I should have been using these all along, apogee and perigee. So perigee being the closest to Earth. So this should be the southern summer, perigee, and it goes back up there, it comes back in, the sun comes back in, only goes as far as the equator, the celestial equator. Otherwise down here it goes right out to 45 degrees south. That's the southern, that's the solstice, December solstice. Up here is July, isn't it? June, July. Northern. So that's apogee. There's seasonal changes. Egyptians knew all about what I've been explaining. These are 23.4 degree ecliptics over the season, because inside the magnetic vortex, the centre of the Earth, the magnetic vortex here turning every day. So the sun is going around every day because the sun's right inside there, and it follows these magnetic fields. And because it's a vortex, the magnetic planes are on this angle because they're winding up, and they come back down, wind back down, wind up, wind down. Fixed in this magnetic field that we cannot see. It's outside our realm. We're created out here. It's a donut. In this part here, right down there is the North Arctic centre. Place of inaccessibility that no one's actually been to. Not sure how wide it is, could be a couple of 100 k's. Then you've got south out here we can't get to. We'd start just collapsing, falling apart, because we just can't get, it's like a magnetic field. You cannot get through it. So there we have it. The Egyptians are showing us, see, this is the sun, see, follows these magnetic field lines. It's the northern summer, southern summer. So from now on I'm going to call it apogee and perigee, not perihelion and aphelion. So bear that in mind. Now Venus, what are we saying here? We've got something up here. The flat earth, we do not live on a ball and we do not move around the sun. So when science starts telling you that we revolve around the sun, it's pure garbage, and they send you right down the wrong track. Earth, sun is up here, it turns in here, 24/7. The sun goes around the earth every day. Earth does not go around the sun. As the sun travels around the earth every day, it is slowly tilting either up to apogee or slowly down to perigee, the southern summer solstice, because the sun follows the tilting magnetic fields within the central vortex. It's a vortex. It's going like this, 24/7, ever so slowly. Everything in here is ever so slowly. And right in there around the sun, this is what the Egyptians have shown us again. In this diagram here with the pyramids in Cairo. The 5-step pyramid de Jure there. It represents the sun up there. And as we are down here, we get to see Venus and Mercury move in front of the sun. The other planets are further out. They're missing the sun. So we don't get to see them pass in front of the sun. They're out here. That's how they work. Otherwise you can go with this idea. And the sun back in there and the planets out here, whatever. This is the best way to understand your visuals. If you're standing down here, that's how you see it. They're too close to the sun. Now, we're going to talk about Venus and its cycles. Can't be debunked. It's quite easy to explain, really, if I can get it out properly. Now, if you've seen my videos before, you realise this is the cosmic egg, the actual cosmic egg, where the sun sits. This is the black hole. That is the black hole, circular, but because the sun has been created inside the black hole there, from the action, the dual system around the perimeter, the two spinning fields, the spinning field that way and the spinning field comes up that way, and bang, they meet and create the voltage, which is the sun. You call it plasma if you want. But, just like an electrical circuit down here, build up the current and you get a cross current, bang, you get the voltage, and that's our planet, that's our sun. So it's bang inside the black hole here, and the sun moves around 24/7 every day. It turns like this. So because it's back here, the black hole's here, daylight is out here. It's projected across the black hole, out that way. So there's daylight. This is the back of the sun, night time. And these are the planets around here. They're not on elliptics. They're just the position, the shape of the sun and black hole make them appear to be on elliptics. You see it's further away at this point. All of a sudden it's in the sun's glare right there, right in front of the sun. But around here it's very close again, and it comes away. That's what gives science the appearance that they're doing elliptics, moving further away from the back, lining up with the sun. To do with this, nothing to do with these out here. Anyway, back to Venus. So I've drawn Venus there, right? So let's say, now Venus moves ever so slowly. It moves with the sun, with the black hole, at the speed of the sun. So the sun's turning every day, so is Venus. But the sun being at the centre of the cosmos, its projection, it moves quicker than every other body out there. It's the centre. So the sun, even though Venus and the sun moved at the same pace, but pretty well, the sun moves out a little bit quicker. So you can imagine there's daylight, it's the sunny side. Draw the sun here. We'll draw the sun there, put the sun in red, so don't get too confused. There's the sun. The actual sun's back here, but we'll say it's there. It's getting projected across the black hole. Let's go up to Venus and start at night, shall we? So basically Venus is a moon. Like all the planets, they're electrons. They act like the moon. They all phase in and out as they go around the black hole. And science wants you to think they're being illuminated by the sun. But that's not correct. What you've got to get your head around is the fact that everything out here is a projection. Everything is projection. Out in our realm is a projection from in here. Whatever's projected out here will not affect another projection. It's all based in here and what's going around the sun. What's going around in here. Let's put this centre there, it's centre there. So, where was I? Going around the sun, going around the sun, going around the sun. Lost myself already. Let me go back to this. Okay. Moon phasing. That's right. Venus being a like a moon, it phases. So what happens is it's following the sun all the time, but slowly the sun is getting ahead of it, just like the sun gets ahead of the moon, our moon. It gets ahead of every other planet. So eventually, what's happening with Venus is it works opposite to our moon. So our moon at new moon is directly in front of the face of the sun. You cannot see it, it's dissolved. The moon forms a skin. You've got to get that in your head. And it dissolves as it gets close to the sun. It goes neutral because the sun's positive. And then when the moon winds away from the sun, closer to Earth, it's going positive because Earth is negative. It's in previous videos. Anyway, so when the moon winds up to the sun, it phases away and disappears into the face of the sun as they both turn together in the broad daylight. You don't see the moon for 2.2 days before the sun finally gets ahead of it, and then the moon comes out as a crescent, then starts its monthly cycle again. Well, Venus works in exactly the opposite way. Its full moon is in broad daylight. Its neutral is behind the sun at night. That's how it works. So there's night time at the back here. So once Venus is behind the moon, behind the sun, it's phased out, neutral. You cannot see it at night. That's why we don't see it at night. And because it's always moving with the sun, always stuck there at night, but eventually the sun is racing ahead of it. So, I'm doing this again. So there's all night time on this half. So it's neutral, and then finally it starts coming out with a crescent, and it's new moon, and that's when it starts appearing early in the morning, just before sun up. So sun up, let's say 6 a.m. there, sun up, but just before it, say there, it starts being seen. Okay, right up until dawn, and then as daylight comes in, you'll no longer see it in the glare of the sun, obviously. So remember, it's always moving together, so it takes a lot of these daily cycles of, to finally have the sun slowly race ahead of Venus. So over the weeks, months or weeks and weeks and weeks, it's slowly moving around because the sun is moving away from it. And look where full moon is. Full Venus moon is bang on in broad daylight. So you never see it. We never see those phasings. And then it's going to start waning. Waning over a long period of time. And it's broad daylight, and then you start coming into evening. So it's phased right down now. Now you're going to start seeing in the evening sky after the sun set. And look, see? And the maximum we get to see it before it completely disappears is only about 3 months, I think, to about this point. And then all through that it's disappeared, so you don't see it at night. That's how it works. All those months, and then finally new moon starts coming out a little bit. You see it in the morning sky, night sky, just here, before daylight hides it. That's how it works. Pretty straightforward on a flat earth. So imagine that all going on in there. or on the centre here, all projected out like a clock arm, like the sun. Imagine the sun's direct frequencies all the way around like a clock. That's how it works. Pretty straightforward. So I'll read you some stuff I've got on the phone here from science. What do we got here? Where that came from? What's that? I'll go to photos. It's all on photos. Photos. Okay, the last photo was Venus. 224.8 Earth days. So the Earth has to go around 224 times before Venus does its one full cycle. And no, now look, I was asking this question. What time of the year is Venus' greatest elongation over its 8-year cycle? And if you've been following me and you know all about this, you're thinking, you're going to realise, like I've just said before, that goes all the way up to 45 degrees south, this December solstice. That's going to be the furthest elongation in these elliptics here, elliptic tilt magnetic fields. Right out here, the sun's going to be projected right out to here. So I'm thinking, well, that means Venus's longest elongation will be in summer, the southern summer. So I put the question in there. Sure enough, you cannot debunk this whole model. The answer is 8th of November, 6th of November, right out there, because these elliptical tilts, the planets follow on these elliptical tilts. And that same elliptical tilt is where the sun is projected. Its frequencies are projected out. Light is frequencies. It all sits on all the atmospheric layers here. 7 atmospheric layers out here of gaseous different pressures. All add up to the, all containing the light spectrum, our light spectrum, all add up to a sun disk that sits on the top from where we see from down here. So there you go. It says, note that each event occurs on November the 6th, and they're spaced 8 years apart, because as it's like that, it's also turning like this. The whole thing's turning like this. So it winds up and winds down over the year. So you've got to imagine this angle, where it is, its position over the year, or after 8 years, happening at that hitting that long elongation, that point. You've got to understand how it works. So the sun's up here, and it's going to be pointing down there. That's now, I have to call perigee, right out. As it slowly moves up, it's not going to be right at anymore. It's not going to be at elongation anywhere up here. It's going to have to wait till you come back down to here again to meet at the precise place. You've got to, Venus has to be in that location. It could be around here somewhere at this stage, up here. But in 8 years' time, it's back facing down there, lining up. Put that out of the way. Right, the moon's orbit around there. There's this elliptical. What's this? There's apogee and perigee, yeah. Okay. Venus will pass very close to the sun in the sky as its orbit carries it between the sun and Earth. See, forget that. It's nothing to do with between the sun and Earth. So you've got to imagine that it's you. You're looking from Earth up. Get rid of Earth between the planets after Venus. Pure garbage. It's really hard to do these videos when everyone thinks they live on a spinning ball. So you've got to try and understand the spinning ball garbage so you can relate it back to this. And it gets pretty complicated because they're two totally different. To get people to understand, you cannot transition some dude within even an hour or two from believing he lives on a spinning ball to flat earth. It's got to go in segments. I tried my best the other night at a party. He's gone away thinking, that's for sure. But I can't be debunked. You put anything to me regarding the spinning ball, I'll show you how it works on this flat earth. What are we up to? That's what Venus looks like. It's nothing. As I just say, it's covered in cloud. Now, if you go to this BS site of NASA's NASA site, it's got science, more science. It's NASA, Venus. Oh, I've lost track. This goes over. Been doing this over several days and 4 attempts. It's pretty tricky to remember everything off the top of your head. But anyway, NASA has a site on Venus full of absolute garbage about volcanoes and this, all this stuff all over the planet. When the other sites will just tell you, no, you can't see it, it's blank, which is truthful. So, what have we got here? Orbits the Sun. Oh, lots happened between me starting to do this. Here we go. Let's get back here. Yeah, right. With the telescope. Even the most modest of telescopes immediately reveal that Venus does not have the same characteristics of a star. The planet either looks like a disk or a crescent. So we do not see full moon, Venus, or neutral moon. We just see those two sides, either morning star or the evening star, as crescents before it starts going to its full moon or before it's going neutral. The planet either looks like a disk or a crescent, which is quite interesting to see. One could even say it's like a miniature moon. I need these other glasses. As for its surface, there is unfortunately not much to see, for Venus is constantly shrouded by a thick white cloud, which do not reveal any significant details. However, these clouds are what makes Venus shine so brightly and remarkable. That's one side. What have we got here? Tiny shifts in the star's apparent position. The new release offers measurements of what sideways motion for all 1.3 billion stars, plus radial, I don't know what that was referring to, rather than moving circles. Per hour. Oh man, I can get organised. Oh, I've lost some of my photos. Interesting stuff to read here. Speed of motion typically important. What's this guy? Alright, bear with me. What's going on here? What the heck? There's so much to think about, you see. Let's read this. Venus does resemble a little moon, however, in that it appears more or less half illuminated in the telescope when near greatest elongation. Now, let's go elongation. With this elongation. Show some elongation. So we've got the egg, the cosmic egg, and there's the sun, and it projects through this way. The greatest, so you're seeing it from here, and during the day, elongation would be way out here because it's the furthest point out here. This is the wider part of the egg, isn't it? So they have it out here. This is the greatest elongation. That would be the minimum, wouldn't it? Back in here somewhere, because it's come right in here. That's what they're calling elongation. And then they call this, because these are inferior, because they're supposed to be between Earth and the Sun, which it's not. They call them inferior. So when we see Venus and Mercury in front of the Sun, this is an inferior conjunction lining up, and we're seeing it from here, right? More confusing information. It shows this phase now because around this time this would be blah 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 blah. Remember, it is easier to view Venus's phase through a telescope in a daytime or twilight sky, because a true nighttime, a glare of Venus itself can be overwhelming. There's some more BS, because all this is in the Milky Way. You see, and when the Sun turns, you're seeing the back of the Sun. When the Sun sits in the Milky Way, it's tucked in the Milky Way. You look up there in the Milky Way, with a good telescope, you get the bright light. I think they're referring to that. You're looking, because that's where Venus will be behind the Sun. You're seeing that big glare. They're trying to tell you that's Venus's glare. That's the back of the Sun. That's how it works. The Sun represents Christ. Christ is tucked in a manger. The Sun is tucked into the Milky Way. It's like the eye in the crocodile the Egyptians show us. You get some pictures of the Milky Way. You see the eye there, the bright light there. That's the back of the Sun, trust me. And more on Venus. As Venus moves around the Sun, you see more of the part of the planet facing the star. Venus seems to grow from a crescent to a semicircle. When Venus's orbit is on the far side of the Sun, you can see most of the surface that is reflecting. See, this goes into just garbage. They all tell a different story too. This occurs once every periodic cycle. So it's 582 days for Venus to go around the Earth. No, it goes around the Earth every day with the Sun. But, yeah, to explain that one.